On the 24th of May, 1863, the professor Otto Lidenbrock, flipping through an old book he had bought the day before from a second-hand bookseller, found an encrypted manuscript in it. His nephew and assistant, Axel, helped him decipher the manuscript. It said that the crater of the extinct Icelandic volcano Snæfellsjökull was the entrance to the underworld. The professor and his nephew traveled to Iceland and descended into the Snæfellsjökull crater. Thus, they got inside the earth and discovered a whole world inhabited by dinosaurs. This is a very brief retelling of Jules Verne's science fiction novel, Journey to the Center of the Earth. In addition to Jules Verne, many other writers spoke in their science fiction works about cavities inside the earth, inhabited by prehistoric animals and people. The idea of the underworld appeared in ancient times. For example, the ancient Greeks believed that Hades, the kingdom of the dead, was located inside the earth. The Japanese underground world is called Yomi no Kuni, the world of darkness. One of the main deities in Shintoism, Izanagi, went down Yomi no Kuni in the hopes of retrieving his wife. He was able to escape from there alive, but did not manage to return his wife. And the ancient Scandinavians talked about their underworld, Svartalfaheim, where the black elves or gnomes lived, known as great blacksmiths who created weapons and magical items for the gods. Edmund Halley was an outstanding British scientist who made significant contributions to the sciences of astronomy, geophysics, physics, and even demography. The famous comet that flies through our solar system every 75 to 76 years is named after him. Halley described the Earth as consisting of a hollow body about 500 miles thick, with two inner concentric shells around the inner core. He thought that the cause of the northern lights was the luminous internal atmosphere of the Earth's cavities. In the early 19th century, the American Army officer John Cleves Sims Jr. argued that the Earth was hollow inside.
I declare the Earth is hollow and habitable within, containing a number of solid concentric spheres, one within the other, and that it is open at the poles 12 or 16 degrees. I ask 100 brave companions, well equipped, to start from Siberia in the fall season with reindeer and sleighs on the ice of the frozen sea. I engage we find warm and rich land, stocked with thrifty vegetables and animals, if not men. On reaching 1 degree northward of latitude 82, we will return in the succeeding spring.
In the early 20th century, Marshall Gardner patented a model of a hollow Earth with a star inside. However, the concept of a hollow Earth is refuted by many scientific data. For instance, the strength of the Earth's crust is not sufficient to hold the roof of a large cavity inside the Earth. It will simply be crushed by the weight of the overlying rocks. And for the birth of a star, a mass comparable to that of the Sun is required. It is not clear how such a large star could fit inside the Earth. What is inside the Earth, and how can people find it out? In order to understand the structure of the Earth, scientists study tremors and vibrations of the Earth's surface, the so-called seismic waves. Such waves are observed during earthquakes, which often occur in various parts of our planet. What do scientists say?
A seismic wave is an elastic wave generated by an impulse such as an earthquake or an explosion. Seismic waves may travel either along or through Earth's interior, body waves, or near Earth's surface, surface waves. Seismic waves travel both along the surface and inside the globe at a speed depending on the mechanical properties of different strata of the Earth. Cross-section of the whole Earth, showing the complexity of paths of earthquake waves. The paths curve because the different rock types found at different depths change the speed at which the waves travel. Solid lines marked P are compressional waves. Dashed lines marked S are shear waves. S waves do not travel through the core, but may be converted to compressional waves, marked K, on entering, and then exiting the core, PKP, SKS, SKP. Waves may be reflected at the surface, PP, ppss. Analysis of the various types of waves reveals structures within Earth. Very little is known about the deepest part of the Earth, the core. It is assumed that it is very dense and hot, over 6,000 Celsius. The uppermost layer of the Earth, the crust, has a thickness from 5 to 10 kilometers, under the ocean floor, to 70 kilometers. Between the core and the crust, there is a viscous and hot layer, the mantle. Its temperature varies from 3 to 4,000 degrees in the lower layers to 701,000 Celsius closer to the Earth's crust. The mantle can be compared to very thick hot tar, with hotter areas slowly rising and cooler areas sinking. The Earth's crust, lithosphere, looks like a mosaic. It consists of individual, tectonic plates. This map shows 15 of the largest plates. The lithosphere exists as separate and distinct tectonic plates, which float on the fluid-like, viscoelastic solid Earth's mantle. The relative fluidity of the mantle allows the tectonic plates to undergo motion in different directions. In some cases, where the temperature of the mantle is higher, or when plates collide, their lower strata begin to melt. This is how magma is formed, a thick mass of molten rocks with gases and water vapor. In places where the strength of the Earth's crust is low, magma breaks through it, and a volcanic eruption takes place.
A volcanic eruption is a horrifying and dangerous event, often tragic for people. Still, when volcanoes aren't active, less dangerous, but no less interesting phenomena associated with magma can be observed in their vicinity. It is worth flying to Iceland for this. Iceland is an island in the northern part of the Atlantic Ocean. The Snæfellsjökull volcano, which Jules Verne described in his novel as the entrance to the underworld, is located in the west of Iceland. This is a place with one of the highest levels of volcanic activity in the world, as the island is located at the junction of two tectonic plates. The map showing the Mid-Atlantic Ridge splitting Iceland and separating the North American and Eurasian plates. It also shows Reykjavik, the capital of Iceland, the Hverir area, and the locations of some of Iceland's active volcanoes, red triangles, including Krafla. It is no surprise that Iceland has plenty of hydrothermal springs, the water in which is heated by shallow bodies of magma, molten rock. The Gunniver geothermal field is located in the southwest of the island. They say that once upon a time, in the vicinity of this field, the ghost of a woman got into the habit of scaring the local peasants. A priest gave them a ball of threads and said that the ghost would calm down there, where the clue would come unwound completely. The ball uncoiled right in the place where the underground boiling water is now gurgling. In Iceland, geothermal sources are used to generate electricity. On the Gunniver field, the Reykjanes power station is located. A geyser is another phenomenon associated with volcanic activity. It's a hot spring that periodically releases fountains of hot water and steam under pressure. Cold water gradually fills the concavity heated by magma, boils in it, and the created steam pushes the water out of the geyser mouth. In ancient times, the Icelanders called one of the geysers in the Haukadalur Valley the Great Geyser. In our time, eruptions of the Great Geyser occur extremely rarely. In 40 meters away from the geyser, there is a geyser called Strokur that erupts every 6 to 10 minutes, releasing water to a height of 16 to 20 meters. Iceland has many fumaroles, i.e., cracks or holes located on the slopes and at the base of volcanoes, which are a source of hot gases. These gases contain various sulfur compounds that settle on the soil around the fumaroles. Another phenomenon associated with volcanoes is a mudpot or mud pool, holes from which dirt and gases constantly or periodically erupt. Hverir is a hot mud spring area located in northeast Iceland near the Krafla volcano. Standing on the deserted orange-red field Hverir, you can easily imagine yourself being on the surface of another planet, for example, Mars.